All right, guys, this recording is for section 12.1. The title is called Sequences. So we are going to start out with defining some of these vocab, and then we can move on to a few examples on the bottom, okay? Okie dokie, here we go. Sequence is a function whose domain is the set of all positive integers. Is the set of positive integers. Series is the sum of all the terms of a sequence. Is the sum of all the terms of a sequence. All right. So we have the word terms. Terms are the numbers in the sequence. Terms are the numbers in the sequence. Factorial symbol. Usually we use this symbol right here. So n factorial, meaning that it's n times n minus 1 times times 3 times 2 times 1. Okay, so if I don't want to use the dot, I can use parentheses to represent multiplication. For n to be greater than or equal to 2, because there are some special things with factorial. If n is not 2 or greater, like n is 1. So if it's 1 factorial, it's really 1. Also, if it's 0 factorial, it's, guess what? It's not 0, it's also 1. Okay. Now, so factorial, it's really factorial is going back to probability. Okay. So if you have 0 factorial, that really means how many ways, okay, how many ways can you arrange 0 items? Well, there's only one way, okay? There's one way to arrange 0 items. It's just because what happened when we have nothing to arrange, okay? There's nothing. Then 1 factorial really means how many ways can you arrange one item? Well, one way to arrange one item. So for example, you have one book. How many ways can you arrange one book on the shelf? It's just one way. Now, what if you have 2 factorials? Okay, so what if n is 2? This means you have 2 times 1, which is 2. Okay, that means how many ways can you arrange 2 books? Well, there are 2 ways. Okay, so you got one book go in the front, let's call it book 1, and then book 2 go in second. Or that's one way. Or you can arrange it, book 2 go in the front and book 1 go in the back. So there are 2 ways of arranging it. So n factorial, think of it as how many ways you can arrange items if you are in probability and AP Stats class. Okay, but in here, we're just going to calculate the number. So what if I ask you to find, like, for example, i.e., 8 factorial, okay? 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's a huge number, okay? 8 factorial is a ginormous number. It's 40,320. So that's what 8 factorial is, okay? So how many ways can you arrange 8 books? Take a wild guess. You're right, 40,320 different ways. Okay. Now, so here is a question for you. Do you think 10 to the 100th power, which is called Google, is it bigger than 70 factorial? Okay. So the next time I see you, you can give me an answer. And if you have a graphing calculator, is it possible for you to do 70 factorial in your calculator? Okay, do you even know where the factorial symbol is? Okay, so try to figure that out with your calculator. If you don't know where the factorial button is, you can totally ask me in class, okay? Next, recursive formula is a sequence, that requires you to find the values of all previous terms in order to find the value of a sub n. Okay, so recursive formula is a sequence that requires you to find the values of all previous terms in order to find the value of a subscript n. What that means is that if you want to find the fifth term, that means you have to find the first four terms first. Okay, so that's what that means. Fibonacci sequence. Okay, it's really well known. Most movies that you watch that has a little bit math involved, they always bring this up. Okay, is a series of numbers. Starting with 0 and 1. So, comma, starting with 0 and 1, where a number is found by adding up the two numbers before it. Okay, so Fibonacci sequence is 0, 1. Okay, for you to find the third number, it will always start with 0, 1. And it will always be the same sequence because it has a name. It has a Fibonacci sequence. That means it's created or was created by Fibonacci. So the third digit is going to be 1. The fourth number is going to be 2. Remember, you're always adding the first two numbers. So the next one is 3, the next one is 5, the next one is 8, the next one is 13, and so on and so on. Okay? Summation notation is a concise way to express the sum of a sequence. So let's say that I'm going to give you a sequence such as this. So IE, okay? IE. A1 plus A2 plus A3 plus, skip a few, plus A sub n, okay? Mathematicians were quite lazy, I would say, right? Because we just want to think and we want to come up with creative ways to do math. So instead of writing it out like 100 times, that's a waste of time. We don't have time to do that. We need a shorter way to write that out. So what's happening is the bottom number right here. Okay, so I want to start at the bottom. And first let's talk about how do we write this summation notation. Summation notation is like an E, like that. Do an E like that, okay? The bottom number, is, you're telling me what you're starting with, okay? So K equals 1. That means my first term is 1. Then and then on the top is where it ends, okay? So This is where it ends. This is where it begins. Okay. And then on this side number here, which I'm going to write in rainbow, is what do I do? What do I do to get all of them? Okay, so A subscript K. So if K is 1, then that's my first term. If K is 2, then that's my second term. If K is 3, then that's my third term. If K is N, then that's my nth term. So this is a quicker way to express the sum of a sequence. Okay, let me give you another example. So another one, let's do 1 square plus 2 square plus 3 square plus 4 square plus, skip a few, 9 square. Okay, this one, we know where it ends. So I'm out of space there, so I'm going to go over here. So how do I write the summation of this sequence? We write the big capital E looking symbol. I will start with K equals 1. No, K doesn't always have to be 1. K can be 0. K can start a different number. Okay. When K is 1, okay, and then that's my beginning value. Now, where do we end? We end at 9. So we don't have N on the top because now we know where we end. The last number is 9. Now, how do I get each digit? What happened is when K is 1, I would have 1 square. When K is 2, that's my second term, right? When my first term is 1. So what's happening is, hey, what can I use? Over here is sort of the formula. So what you just do is just write K squared, because each value of K you put in, that will give you each term until I go to K equals 9. Then that is my last term. Hence, this is the end of it. And this is the beginning. Okay, so you got the end and the beginning. Properties of sequences. Okay, we have 4 of them. So here we go. If the set of A sub n and the set of B sub n are 2 sequences and C there you go, and C is a real number, then here we go. Case number 1. The summation of K equals 1 to the nth term of C times A subscript K equals, so if I give you the summation of starting at K equals 1 and it ends at nth term, and C, according to this definition here, C is a real number. That means it can be anything it wants to be, okay, and times A subscript K. Then this is the same thing. It's just saying C times A subscript 1 plus C, whatever C is, times A subscript 2 plus, skip a few, C times A subscript N, okay, which is the same as taking out your C, because that's what C is. They all have C in common. It's just that real number. Then we can just go ahead and add A1, A2, skip a few, A sub N, okay, so those are equivalent. Well, if those are equivalent, that is also equivalent to the summation. Again, K starting at 1. It's the same thing as adding all the A's first, then multiplying by C. Okay, and we end at nth, and it's going to be A subscript K. So what this is saying that, hey, if I have C, the summation of C, A subscript K is the same thing as saying that do the summation of A subscript K first and then times it to C. Okay. 2. The summation starting at K equals 1, it ends at nth of A subscript K plus B subscript K, okay, in quantity. Then this is the same exact thing as if I were to break it up as two summations. Okay, so it has this property. So these are the rules. So if you have the summation of a subscript k plus b subscript k in quantity, then it's the same thing as I can break these out. Okay. Number 3, I'm just going to write it over here because I'm kind of out of space. If I have the summation k starting at 1 to the nth power quantity of a subscript k minus b subscript k. It's very similar to your addition. I can break this up into summation of k equals 1 to the nth of a subscript k, take away summation of k equals 1 to the nth of b subscript k. Okay, so the addition of summation and the subtraction of summation, you can break it up. And for our last property of the sequences, if I have the summation of k equals 1 to the nth power of a subscript k. This is, oops, my bad, we don't start at 1 anymore. Of things that don't start at 1, okay? Like j plus 1, okay? And j, it's whatever it wants to be. And then we're going to define j in a little bit, whatever positive number, I should say, that it wants to be, okay? So again, the summation of k equals j plus 1. What this is really meaning that I don't want it to start at the value of 1. Then I can turn it into, what if I want it to start at 1? In a little bit, we are going to do problems that things don't start at k equals 1. And usually we want it to start at 1 because it's easier, right? But sometimes that doesn't really happen. Okay, so how do we bring things back so that way it can start at 1? Then here's the rule. We will do summation of a subscript k starting at 1 to n minus the summation of k equals 1 of a subscript k to j. Okay, and what on earth is j? Where j is greater than 0 and less than n. Okay, so let's say n is 9. Okay, that means j can be 4. So that means this is really starting at 5, right? If j is 4, well, I don't want it to start at 5. Okay, I want to count starting at 1. Then I can start from 1, okay, to 9, and then take away, oops, I didn't finish writing. This is k equals 1. Okay, take away 1 to 4. Okay, so that gives me 5 to 9. That's all that is. Okay, and if this is confusing, it's totally okay. We will do problems, and that will be using these, just like all of our definitions. At first, it sounds scary and it looks scary and it sounds confusing, but it's just a language. Once we put it to use, they will make a lot more sense, okay? All right, formulas for sums of sequences. So we have 4, okay? These 4 you should really know if you want your life to be easy, okay? Summation. I know my summation symbol is quite ugly. I think your book does a better job like that, but I just can't do it by hand. So I'm just writing E, really. So formula for sums of sequences. That means I'm going to add up all the terms now. So starting at 1, k equals 1 to the nth power. If you just have c. Then what happens if you just have c and you want to add up all the c's? But just really what that means is c plus c plus c dot 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 plus c. That means you have c times n, okay? What is c then? C belongs to any real number. C can be 1.5, 1.2, whatever c wants to be, okay? 2. Let me just give you a quick example, i.e., okay? Summation k starting at, let's say, 1 to 4, okay? And c is any real number, so let's pick 2. So that means, what do I do with that? What does that mean? This means when k is 1, okay, my first term, when k is 1. It doesn't really matter because I just have 2. The next sequence, when k is 2, I just have 2. The next one, I have 2. And the next one, I have 2. Well, the summation, I have 4 terms because it ends at 4. The summation means I need to add all of these. Okay? So when I add them all up, it's just really 2 times however many terms I have. Okay? So this is n right here. So that's why this is 8, or c times n. Okay? So that's how they come up with that formula. All right, next. I have a summation starting at 1 to the nth, and I have k. Okay? So when k is 1, then my first term would be 1. When k is 2, then my next term would be 2. Okay? So when k is 1, it's 1. When k is 2, then it's 2. When k is 3, then it's 3. And so on until it's nth term, right? That's my dog wanting to come in, and I just can't pause right now. So what's the formula if I want to add them all up? You're not going to sit here and add, if n is 100, you're not going to sit here and put this together, okay? If n is 500, you're not going to sit here or on your calculator do 1 plus 2 plus 3 plus 4 plus 5 500 times. So you want to come up with a formula. So the formula is n times n plus 1 all over 2. So i.e., okay, if I have the summation of k starting at 1, that's n is 10, and then I just have k. So what this means is I have 1 plus 2 plus 3 all the way to plus 10, right? So instead of just sitting here and adding it all together, you can go, well, 10 times 10 plus 1 all over 2, which is 10 times 11 all over 2, which is really, we can reduce those. That's really 5. So 5 times 11 is 55. So that's kind of how we think of it. All right, 3. The summation starting at 1 to the nth, and what if you have k squared? So the first term, k squared, is still 1. Second term, 2 squared is 4. Third term, when k is 3, 3 squared is 9, plus dot dot dot, plus n squared. So just like number 2, you're not going to sit here, if n is like 99, you're not going to sit here and do it 99 times in your calculator. So you want to come up with a quick formula, so that way you can come up with the sum. The sum means the final answer of all of that. So that's the formula. There will be a class in college that you will take, or if you want to take, I should say, if you're going to be a math major, that will prove all of these, or will help you explain why we come up with all of these. Well, I think that's even in calculus. Maybe next year you will. Okay. The summation of starting at 1, again, k equals 1 to n. What if I have k to the third? So when k is 1, 1 to the third is 1. When k is 2, 2 to the third is 8. When k is 3, 3 to the third is 27, and so on, plus n to the third. Well, all right, here we go. Formula for this is going to be n times n plus 1 all over 2. Well, that looks too much like k, right? So that can't be right, because this is k to the third. So what's happening is we're going to take the quantity of that all and we square it. Okay, so that is the formula to the third power. Example 1, evaluate the factorial expression of, here we go, 10 factorial times 3 factorial divided by 8 factorial. So, oh, my pen's frozen. There you go. Okay, so what that means is, remember, 10 factorial is the same thing as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then 3 factorial is 3 times 2 times 1 all over. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So as you can see, these are all canceling. Okay, so if those cancel, we have 10 times 9 times 8, and then at the end times 3 times 2 times 1. So this is going to give you a nice answer of, let's see, that's 90, right? 90 times, this is 8 times 6, 48. So 90 times 48 is going to give me what? Oh, I'm sorry. Oh, wait, the 8's already canceled. I lie. So that's not 90 times 8 anymore. So it's just 90 times 6, which is 540. Okay, so that 8's cancel. I forgot. Okay, now is there a quicker way? Sure, of course. Okay, so if you see that this has an 8 factorial on the bottom, you can do 10 times 9 times 3 factorial, okay, times 3 factorial is, oops, 10 times 9 times 8 factorial, and then 3 factorial is 3 times 2 times 1. So what's happening is 8 factorial on the bottom will also cancel one another out, so you don't have to write out 8 times 7 times 6 times 4, okay? So if you know that's canceling, and that's still gonna work out to 540. All right, next, example 2. Find the first 5 terms of the sequence called D subscript n. Okay, find the first 5 terms is just meaning that you're gonna let starting with 1. Okay, so let's do it. First term, D subscript 1. That means when n is 1. When n is 1, you're gonna do some basic math. Here's -1 to the n. It's 1, so I'm going to fill in 1 right there. 1 minus 1 times 1 all over 2 times 1 minus 1. Okay, base that up. So that will give me, this is the exponent is 1 minus 1 is 0. Any number raised to the 0 power is 1. Okay, times in quantity. On the bottom, that's going to give me 1. 1 divided by 1 is 1. So my very first term is 1. Okay. Then what happened when n is 2, subscript 2? Then I'm going to do the same thing. -1 to the, anytime I see an n, which there are 3 different places, okay, I will put in 2 as the value. So -1 to the power of 2 minus 1 times, now I see an n on the top, so that's 2 divided by 2 times 2 minus 1. Box that up. I'm sorry, not box that up. Put the closed parentheses on that. So now we will simplify. 2 minus 1 is 2. -1 to the 1 power is still -1 times 2 over 2 times 2 is 4 minus 1 is 3. So this second term is -2 over 3. My third term is when n is 3, so very similar. I'm just going to do exactly what I did the first 2 things. So 3 minus 1 is the power. Then I have 3 over 2 times 3 minus 1. Close the parentheses, close the bracket. This will lead me to, let's see. 3 minus 1 is going to be 2. -1 to a second power is now +1 times 3 over 2 times 3 is 6. 6 minus 1 is 5. So this is going to give me a positive 3 over 5. Okay. Now, I think I brought this up before. Anytime you have a -1 in the front, okay, this right here, that means you're going to have the signs are changed, okay? So with each term. So that's why the reason why there's a -1 there. All right, my fourth term, I'm out of space. All right, open bracket, -1 to the 4 minus 1 times 4 divided by 2 times 4 minus 1. Close the parentheses, close the bracket. All right, let's do some basic math. 4 minus 3 is 3. 4 minus 1, I'm sorry, is 3. -1 to the third power is -1 times 4 over 2 times 4 is 8. 8 minus 1 is 7. So this is giving me a -4 over 7. Okay, so those are the first 4 terms. Now, I need to do 5 of them because it said so. All right, du5 equals, open bracket, -1 to the 5 minus 1, open parentheses, 5 divided by 2 times 5 minus 1, close it another time. Here we go. -1 to the 4th power is +1. 5 divided by 2 times 5 is 10. 10 minus 1 is 9. So this is going to give me a positive 5 over 9. Okay. So what do we do with all those 5 little things that we found? We put it together as a set, okay? So I'm not picky on how you write these. Oops, I meant negative 2/3. You can use the bracket. Okay, I'm not gonna deduct points if you don't, but it just looks pretty with the bracket. So these are the 5 terms we found. Whoop, 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 whoop. There it is. Okay. Example 3. The given pattern continues. That means ... mean it doesn't ever end, okay? Write down the nth term of a sequence. They want to call the sequence a subscript n, suggested by this pattern, okay? What this means, guys, okay? Write down the nth term. What this means is it wants a formula, okay? Formula. So that means any term, any nth value I plug in, I should be able to get that value right away. Okay. So I'm gonna talk it out to you so you can what I'm thinking or what should I be thinking when I'm working these problem out. Okay. So first, when I see these, I'm gonna say, first term, second term, third term, fourth term. Okay. And the reason is that I want to see if there are some sort of a pattern, okay? If I want to keep on going, my 5th term would be 1 over, well, the first term has a 1 on it, the second term has a 1 on it, second term has 2 on it, and then the third term has a 3, and fourth term has a 4. So if I had to guess, the 5th term would have the 5 times 6, right? According to the pattern. So if I keep going, if it's nth term, I would say, everything has a 1 on the top. If all of these has that term right there as an n, and these one looks like it's just 1 more than nth term, then that's just going to be an n plus 1. Okay, so guess what? That is your a subscript n. Okay, so I came up with the formula for any particular place that I want. So if I want to find the 9th term, I can go and use this formula and find the 9th term. Or if I want to go and find the 99th term, I can so do that without listing out 98 terms first. Okay. All right, this one. And same thing, I'm going to start, okay, first term, second term, third term, fourth term, and 5th term. Okay. Well, right now, I kind of don't see much, okay? But I do see that one is positive and one's negative. Anytime that you do see something like that, that means you have a negative 1 in the equation, okay? So let's think about that. Well, negative 1 in the equation, well, the first one, I have to get a 2 somehow, and it's a positive 2. So I need to think about, what would I do to get a 2? I would have to come up with a multiplication, right, of some sort, and I would have a 2 in there somehow. Well, to get a positive number, would you agree, the exponents must be positive. Well, for the exponent to be positive, well, this is my first term, so I'm going to use n. When n is 1, that's not going to be positive. How about if I just go and add 1 more? Okay. Well, when n is 1, which is the first term, 1 plus 1 is 2. Negative 1 to the 2, definitely positive. Times 2, okay, that works. Okay, so right now that works. But what if n is 2? Okay, well, let's test it out, right? Negative 1 to the 2 plus 1. Well, that's definitely negative. Well, times 2, well, that doesn't work. I want it to be negative 4. Okay, so, well, negative 4, isn't that twice as much? Okay, so what if I go in and plug in an n in there? Like right there. Would that now work? Okay, so when n is 1, okay, 1 plus 1 is 2. That's positive, we know that much. N is 1, that is not going to change this value, so that's going to work. When n is 2, 2 plus 1 is 3, negative 1 to the third is negative, and n is 2, so that will give me 4. Check. All right, that works. But don't stop there. Make sure you check all of these, see if it works. When n is 3, third term. So 3 plus 1 is 4, negative 1 to the fourth, positive. At least that works, right? And then 3 times 2 is 6. Yay! And then we test negative 8, okay, to see if we're going to come out negative 8 for the fourth term. N is 4, definitely negative, so that's a good sign. 4 times 2 is 8. So guess what? It's working. So I should box this up as my final answer. So negative 1 to the nth plus 1 times 2n. Now, is this the only answer? No, okay? You can totally come up with something else, and then I can verify that, and then it might work, okay? All right, next question is 4. A sequence is defined recursively. Write down the first 5 terms, okay? So we're gonna, they gave you a sub 1 already, so technically you only have to find 4 more. So to find a sub 2, which is your second term, okay, it says here a sub 2 equals n, which is 2, because that's the second term, plus 3 times a subscript, n is 2 minus 1. But this is really means 2 plus 3 times a, 2 minus 1 is 1. Well, they gave you the first one. They gave you a sub 1 is negative 2. So 2 plus 3 times negative 2, it's going to give you just an answer of negative 4. So that's your second term. So recursive means that you have to know the term before. So that's why it's a pain when it's recursive, because you do have to find the previous term to find the next term. Okay. Same thing with A3 and A4 and A5. Okay. So A3, that means n is now 3. Plus 3 times a, n minus 1, which is really 3 plus 3 times, oops, n is 3, so I should really plug that in. 3 minus 1, which is really 3a sub 2, which is really 3 plus 3 times negative 4. So 3 plus 3 times negative 4 is now negative 9. The next one, a subscript 4, is 4 plus, and as you can see the pattern, this is really just 3 times the previous term. Okay, so after a while, I'm gonna stop plugging it in. I'm just gonna plug in directly what the previous term is, which is negative 9. So if I plug that in straight up, I'm gonna get a negative 23. And since I'm out of space, I'm gonna use a different color so that way you're not lost. Okay, a subscript 5 is now 5 plus 3 times the previous term, and the previous term is negative 23. So now that will give me an answer of a negative 64. So 5 terms are, you can do it as a set, you don't have to. I'm not going to be super picky whether you do it as a set or not, okay, as long as you have all the correct numbers. All right, and that is a box, okay. All right, B, same exact thing, okay? They gave you a sub 1 already, so we don't have to find a sub 1, but we do have to find a sub 2 all the way to a sub 5. So a sub 2 is, it says r is r, so keep r as r, and then times a, and then it says n right here is 2, so 2 minus 1, which is really r times a of subscript 1, which is really r times capital A, okay, because a subscript 1 is capital A, so you can't leave a subscript 1 of a subscript 1. Then a subscript 2 equals r, and by now it's just r times the previous term, so I'm not going to go and plug in all the numbers, okay. Well, the previous term, which is a subscript, oops, I meant to say I want to find a subscript 3, okay, so the previous term is really a subscript 2, right? But the answer to a subscript 2 is this one, so I definitely have to plug that in, okay. So that will get r times a, so r times a is now r squared times a, okay, which is the answer to a subscript 3. Then I'm going to do the same thing for a subscript 4. A subscript 4 is going to be r times a times the previous term. Well, I have r the previous answer is this one right here, so that's where that's going to go, r squared times a. This one is easy to see a pattern where this is going, but not all the time that you're able to do that, okay? And then the next one, I'm going to do the same thing. A subscript 5 equals r times the previous one, which is r times, the previous answer is this one right here. I'll use red to fill that in, so that way you can see where that's coming from. So this answer is going to be r to the 4th times a. So I have 5 terms, r squared a, r to the 3rd a, r to the 4th a, and the first term they gave it to you, which is a. So box it up. Those are the 5 terms. As you can see, this time I'm not using the set notation. No big deal. Okay. All right. Example 5. Write out each sum. Okay. Are you ready? What does that mean? That means I want you to write out every single term. Well, this is not possible because it starts at 1 and it ends at nth. So it's not like it ends on the 9th term where you just write out 9 terms. But you're gonna write out as much as you can. So here we go. 1k equals 1. Then you plug it in. This formula is 2 times 1 plus 1, which is 3. 1k equals 2. Then it's 2 times 2 plus 1, which is 5. You can do about 3 or 4 to get sort of a pattern. I wouldn't do any more than that. Then that's just going to be a waste of time. Okay. And that's going to be 7. And ... 1k is n. Then it's really 2 times n plus 1, which is 2n plus 1. So it says here, write out each sum. Okay. So we have the summation, k starting at 1, it ends at n, and here's a formula for that summation. Write it out, meaning this: 3 plus 5 plus 7 plus, so everything in between, since I can't write them all. And the last term, because it ends at n, you do have to put it in terms of n in a quantity. Okay, and this, my dear, is the final answer and how you write it out. All right, same thing with this side, except this, look at this, it starts at 0. Whoa, 1k equals 0. 2 times 0 plus 1 is 1. Okay, 1k equals 1. 2 times 1 plus 1 is 3. 1k equals 2. 2 times 2 plus 1 equals 5. And ... 1k. N, 1k equals n. That means 2 times n plus 1, which is itself. Okay. Now, but it says n minus 1. So that's the tricky part. So you can't go to n. You have to go to n minus 1. What n minus 1 is, it's the one before that. 1k equals n minus 1. So it's 2 times n minus 1 plus 1. Simplify that out. 2n minus 2 plus 1, which is really 2n minus 1. Exactly. So don't do things out of habits and stop at n. That doesn't work because that's not where this ends. So you read this right here. It ends at n minus 1. Okay. So what does this mean? It means summation k starting at 0. It ends at n minus 1. Totally okay. Okay, the question is 2k plus 1 is 1 plus 3 plus 5 plus ... plus 2n minus 1. Okay, that's what an n minus 1 means. An n minus 1 is the one before n, obviously. So if you keep going with the habit and you end at n, that's not correct. It's really the one before it, and yes, you have to simplify. Okay. Example 6, here we go. Express each using summation notation. Okay, so now I'm giving you guys a bunch of different numbers here, and then your job is to go back and use your summation notation and then put it together. No, so now I'm sorry. Whenever you guys see these, I would my recommendation is start writing like first term, second term, third term. If that's the third term, as you can see, this is number 8, so that's probably the 8th term, okay? Your summation notation, as you know already, the bottom of the summation notation is where what number we would like to start. Normally, I would say 99% of the time, I want to start with number 1. If we're starting at number 1, based on this sequence, we end at 8. So the top is the number that we would stop. Now we just have to come up with a formula that every time we put in k, it will give us the 1 to the 3rd, or 2 to the 3rd, or 3 to the 3rd. In this case, it looks pretty easy, right? The first term when k is 1, all of a sudden it's just 1 to the 3rd. Second term is 2 to the 3rd, and third term is 3 to the 3rd. So this formula then, every time you plug in k, it's just k to the 3rd, and that's it. Not all the time that is that easy, right? Now let's go to number 2. I'm sorry, not number 2, letter B. Letter B again, I'm going to use, okay, well, I'm going to let this be first, and let this be second, let this be third. And looks like we have n here as our last term. Not all the time that we would be able to have a number or a constant on the top. And again, as I told you guys already, I normally start with k equals to 1. When k equals to 1, so if this is k, right, when k is 1, it looks like it's 1 over e. When k is 2, well, it's 2 over e squared. When k equals 3, 3 divided by e to the 3. So if you look at the pattern, which is what math is, right? Math is a pattern of signs. Would you agree that I can just have k over and then e? But that's not really fully done yet because this e has a power of k as well. So that would be okay to have. Now, where do we stop? Which is we need to write something on the top of the summation notation. We stop at n. So this is the final answer. One more on example 6. So on example 6, I will have first term, second term, third term, and so on and so on. So we can start with, okay, I'm going to start here, k equals 1. For this one, guys, I'm going to do 2 different answers for the summation notation, okay? Some of you like to start at 0, and that's okay. All right, so if we start at 0, so let's say that this is my first term when k equals to 0 here. Let's work on this one first, okay? So when k equals to 0 on the right side, I have a, okay? Now when k is 1, I have a times r. Well, when k is 2, which is my third term, I have a r squared, and then dot, 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 dot. So can you guys see that every time, okay, we plug in k, the power right here is the same as the k if we are starting at k equals to 0. Okay, so with that said, I can go in and say, okay, a is always constant, so I'm gonna keep that. But the variable r changes its power every time I plug in k. So you guys can see that I can just use that as my answer. Now where do we stop? We stop right here. So n minus 1 is where we're stopping. Now what if we start at k equals 1 on the right side? Then you have to go and see, okay, well, if I start at k equals 1, which if I'm using this, I'm going to add 1 here, right? That means I want to n also add 1 there. Now, if I add 1 to the starting position, which is on the bottom of the summation notation, and add 1 to the top, which is the n number of your summation, I would now have an n. Okay, but that doesn't mean you can just go in and just add k, like add 1 to this formula. That's not going to work. So make sure we look at each number, okay, carefully. So what would happen if we plug in 1 to start with. So let's go and plug it in. Okay, ready? When k equals 1, I have an a, okay? When k equals 2, this is my second term, I have AR, so r to the first power. When k equals 3, that's my third term. This is 1 less. So your formula, students, for this one, it's a times r to the k minus 1, okay? So that's what's happening, all right? So those are the two equations or two summation notations that you can have, and either one should be fine. Now, on any equations, you can always come up with different formulas. I just have to verify the answer myself. Example 7, find the sum of each sequence. So now we are going to use the summation they give us to find the sum. The sum means an answer to an addition problem, okay? So that one's super thick, isn't it? Let's see, probably, okay. So for this one, when k equals 1, I have 8, okay? So I need to add that. When k equals 2, I have 8 because it doesn't change, it's a constant. When k equals 3, I have 8. So I'm gonna keep adding 8, guys, all the way to my last k is what? 50. Well, guess what? I'm not gonna sit here and add 8 like 50 times. So this allows you to go back to your formula. Can you guys go find your definition number 9? Okay, so definition number 9. There's a formula that looks like this. It starts out at 1, and then it ends at n, and there's a constant, C for constant, and we talked about this before. Then the formula says you can find the sum by just doing the constant times n, okay? And that's what we're going to do. We're not going to sit here and add 850 times on the test. What if I go, you know, like to 9,000 times? You're not going to sit here and punch in 9,000 times. So we can use a formula. Your C is 8, and your N is 50. We can multiply that out. So if we sit here and add 8 all the way to 50 times, we should get an answer of 400. 400 is the sum. Okay. Let's go to B. Now, before we start B, it says here the summation k starts at 0, which is slightly different from A. K starts at 1, and it ends at 14. Okay, when k is 14. So technically, we can go in and use a formula. If you go and look at definition number 8, I want you to go look and find definition number 8. Okay. There is this formula right here. It says k has to start at 1, ends at n, and then it says a subscript k minus b subscript k is identical to the summation of k equals to 1, ends at n, times a subscript k, take away b subscript k. Okay, so this is already in your definition. Okay, so now you just have to know how to use it. But your definition here says k has to start at 1. Now your formula here, or your question here on 7b said k is currently starting at 0. Then we can't use the formula. That's not the same. So we just have to start with k equals 1 by using when k is 0. Okay, when k is 0, I'm going to plug it in. Ready? 0 squared minus 4, which equals a negative 4. So now I'm going to rewrite this, students. I'm going to have, okay, negative 4 is when k equals to 0. Then I'm just going to do the summation for the rest. I haven't done k equals 1 or k equals 2, k equals 3. I'm going to use the summation from k equals 1 all the way to 14. Okay, all the way to 14. And so I'm going to write this formula, this question back down. So students, all I'm really doing is breaking this up into when k equals to 0, gets the constant here, and then recopy the problem for the remaining k values that we haven't used. All right, so now I can go and use this formula, right? Because now k is starting at 1. So with that said, I know exactly what to do when you have a quantity of summation according to your formula. If k starting at 1, we can break it up. K squared, and then we can do a minus, okay, summation k equals 1 to the 14th, 4. Okay. Now I know you can do this constant because we just got done with one constant here on 7a. So that means the constant formula said it's your constant value 4 times the ending value. That will give you the sum, which is the answer of all those additions, okay? Now we have a negative 4, what's the when k equals to 0. Then I want you to go and look for the formula for this. I'm going to give you a couple seconds to go look for it. Okay, so I hope you found it in the definition 9. And the formula said it's n times n plus 1 times 2n plus 1 all over 6. I'm copying down the formula for you. Well, what on earth is n? N is the n value. So now we can plug that in. Drop down negative 4 plus the n value is 14. 14 plus 1, and then 2 times 14 plus 1 all over 6. Now, I'm just going to multiply 4 times 14 out. That's going to be 56. And yes, you can use your calculator to do your basic math. When you work out the numerator here, that's going to be 6090 over 6, and then subtract 56. And then when you do 6090 divided by 6, that should give you 1015, and then drop down 56. So the sum should give you 955. And that's all, y'all.